After that, you can complete the homework. Okay.
Yes.
So, now, yeah, Krishna, you are facing the problem in this question. Fx is equal to cot x.
Yes, sir. So I'm getting the
Okay.
answer as cosec square x. Is it correct? It's minus cosec square x. Right?
Minus. It is minus cosec square x. Okay. So, can you tell me the formula for the derivative of the first principle? Limit h tends to 0.
Cot x plus h minus cot x.
Yeah, fx plus h minus
F of x by h.
by h. Okay, you will put this formula. So this is limit h tends to 0. This is cot x plus h minus cot x by h. So this is equal to limit h tends to 0. Now cot x plus h means cos. This is cos x plus h by sin x plus h minus cos x by sin x by h. Now take this LCM and you will get sin x plus h minus dot into sin x. So this is equal to sin x into cos x plus h minus cos x. Okay, there is one more formula in trigo which we need to use here. Then you will get a negative. Okay, Krishna, as we have not started the trigo, that's why you are facing the issue. Limit h tends to 0. Okay, Krishna, first of all, tell me that which formula you have used here.
So sin a minus b.
Sin a minus b, very good. So sin a minus b is what? This is sin a cos b minus cos a sin b. Cos a sin b. We have this formula. So if you will check that this is a, this is b. Again, this is a, this is b. Okay, so as per this formula, we should get sin bracket a minus b. A means x, minus b is x plus h by sin x plus h into sin x. This limit h tends to 0. Now this will become what? X minus h. So this will give you minus h. And you have this one, sin x plus h into sin x. Now please remember this, we have this formula. We will do this one in trigo. Sin minus theta is equal to minus sin theta. We have this formula. Okay, so that's why in the numerator you will get this one. This is the limit h tends to 0. Okay. So you get here limit h tends to 0. This will give you minus sin h by sin x plus h into sin x. Now you can put the limits. Okay. We have one h here. I forgot it. This is here. And this here. So sin h by h, this will give you 1. Negative is already there. This will give you 1. You will put the limit here. You will get a sin x. And here you will get a sin x. So this will give you minus cosec square x. Okay, Krishna?
Yes, sir. Got it.
Krishna, this clear? You're on mute.
Got it. Thank you, sir.
Okay, welcome. Krishna, any other doubt?
No, sir.
Okay, very good. Then we will start the next one. Okay, just give me a minute. we have completed till here. Okay, we have done these questions from the first principle method. Only the second and the third one is remaining because we need to discuss the exponential and logarithmic function. After that, you will be able to solve question number second and third. Okay. Okay. So you have completed this 10th also, Krishna?
No, sir.
Okay, then you can try this 10th also. You will not face any issue because x to the power n we have already completed. So it's similar to this one. Okay. Now, okay. Now we have started derivative. We have done the derivative by the first principle method. Okay, so what type of questions we have covered here? We covered this one, where we need to differentiate it by the first principle method. The next type, we need to find the derivative of a function at a single point, at one point. So let's check here. Suppose f is a real valued function. I guess you both have completed the relation and functions in term one. Okay. If not, then we will do later on in details whenever we will get the time. So suppose f is a real valued function. What's a real valued function? Where the domain is always a when the range is always a real number. Now, suppose f is a real valued function and a is a point in its domain. Okay. A is a point which is there in the domain of this. If we need to find the derivative of f, if we need to find the derivative of f, then this will be given by this formula, limit h tends to 0, fa plus h minus fa by h. So what does this mean? Suppose we have the function fx is equal to sin x. Okay. Suppose we have this function and they ask us to find the derivative of this. This we can do and we have already done this. Okay. Now, but what happen if they ask us to find the derivative of this function at 0? That means they ask us to find the derivative of this at x is equal to 0. Earlier, what they asked, they give us the fx is equal to sin x, and they ask us to find the derivative of this, simply f dash x. Now, what they say, they will say to us to find the derivative at x is equal to 0. Okay, so Hotvika and Krishna, question is clear? What type of question can be asked from this definition? Okay. Hotvika, I can't hear you. You can reply me on the chat box. Okay. So now here. Okay, Hotvika, very good. So if we need to find the derivative of a function at any point, then this will be given by this limit. Limit h tends to 0, fa plus h minus fa by h. Provided this limit exists. This limit should exist. Now derivative of function at a is denoted by this one, as we have denoted here. Okay, if you need to find the derivative of any function at point a, then you will denote this by f dash a. Okay, then please note down this definition. Okay, and confirm me. Then we will start some questions on the basis of this definition. Please note on this. And Hotika, please let me know once you complete it.
Done, sir.
Okay, Krishna, very good. Utvika, okay, very good. Okay, so this definition is clear. If we need to find the derivative at any point a, then we will use this formula, limit h tends to 0, fa plus h minus fa by h. If we will compare this formula with the previous formula, then in place of a, we had a x in our previous formula. When we need to find the derivative at any point, that x will be replaced with a. So complete everything will remain the same, just in place of x, we will put a. Okay. Suppose we have this function first one, we need to find the derivative of fx is equal to sine x at x is equal to 0. Okay, so the first one question I will solve, remaining one you need to do. So we need to find, that means derivative of this at 0 is equal to, this is what, limit h tends to 0, f a plus h minus f a by h. Okay, so this is equal to 0. Now what is this? This is 0 plus h minus fa means sine 0 by h. Now this is equal to limit h tends to 0 sine h. Now Krishna, what's the value of sine 0?
It is 0, sir.
0, very good. This is 0 by, this is h. So this will give us limit h tends to 0 sine h by h. Now what is this formula?
1, sir. Sine
1.
is 1.
Very good. Okay, so this is the answer. So the derivative of sine x at x is equal to 0 is equal to 1. Okay, I will tell you one more thing. You have already completed this one, that if we have fx is equal to sine x, then what's the derivative of this? Please check your notebook. We have done in
Cos
the
x,
last
sir.
cos x. Okay, very good. Now what we need to find, in place of x, we need to put 0. So the answer is cos 0, which is 1. Okay, so you don't need to do by this method. You will not do by this. I'm just explaining to you that if you want to cross check your answer, you can do in this way, because finally we will learn all these formulas. Okay, don't get confused. We need to use these formulas, this method only. Please note down this, confirm me, then we will start the next question.
Done, sir.
Okay, Krishna, very good. Hopika, please confirm once this is completed. Okay, very good. Then please start the next one. Find the derivative of this. X is equal to 2. Please let me know if you will face any doubt in this. Hey, Krishna, very good. This is correct. Uh, very good. Hotvika, this question is completed. Okay, okay, okay. Hotvika, this is done. Or if you have any doubt, then you can tell me. Okay, you are not getting the answer. What to do? We will try to solve it. Please check here. With the formula, formula is limitation is to 0. Okay, then f a plus h minus f a by h. What is f a plus h? A plus h means 2 plus h. So this is equal to what? In place of x, we will put this 2 plus h. So 2 plus h whole square plus 1. Next, what we need fa. Fa means we need f2. So this is equal to what? In place of this, you will put 2. So 2 square plus 1, which will give you 5. Now put all the values here. So you will get limit h tends to 0 of a plus h. A plus h means uh, a plus h means this one, 2 plus h whole square, 2 plus h whole square plus 1 minus fa means 5 by h. So this will give you limit h tends to 0. 2 plus h whole square means 4 plus h square plus 2ab 4h plus 1 minus 5 by h. Now this 4 plus 1 and 5 will cancel out. So you will finally get limit h tends to 0. Okay, and here h square plus 4h by h. You can take common h from here. So you will get limit h tends to 0. Take common h. So you will get h plus 4 by h. This will cancel out. So finally you will get limit h tends to 0, h plus 4. You can put this limit here. So finally you will get a 4. Hotvika, this clear? This clear, Hotvika? Okay, very good. And please note down this, confirm me, then we will start the next question. Okay, both people are very good. Please try this question then. Fx is equal to x squared plus 4x plus 3. You need to find this at x is equal to 1. Okay, and let me know if you have any doubt. Krishna, very good. This is correct. Very good. And Hudvika, please let me know if you have any doubt in this. Okay. Hudvika, are you facing any issue in this? Okay, Krishna, I guess Hudvika has some network issue. Okay, then you will start the next one. Krishna, any doubt in the first principle?
No, sir.
Okay, so with the help of first principle, we have derived some results. Now, in the second type of differentiation, we will use that results to solve the questions. Okay, but in your exam, two type of cases can be asked. First, by using the first principle. Second, by using the formulas. So we will check that what are the formulas we have used. First, we have derived, sorry. So first, we have derived this formula. Have a derivative of x to the power n, which is equal to nxn minus 1. Okay, hope you have remembered this formula.
Yes, sir.
Okay, then we will check the next formula, derivative of sin x, which is equal to cos x. We'll check next one. This is derivative of cos x, which is sin x. We have done this one also. Next is tan x, which is sec square x. Next one, cot x, which is minus cosec square x. Next is sec x, which is sec x into tan x. This is cosec x, which is minus cosec x cot x. Okay, so Krishna, please note down all these formulas and learn it. Okay, please note down. And Krishna, please let me know once this is completed.
Done, sir.
Okay, very good. Then we will take some more formulas. Next is derivative of exponential function. We have not completed this one. This we will do later on. Okay, but please note down this. We will drive this result by the first principle method later on. After this, we have a to the power x, which is a to the power x log a. This also we will drive later on. When we have a log x, this also we will do. This one also we will do. Okay, so please note down all these results. We will solve it by the first principle at the end of the chapter.
Done, sir.
Okay, we will try some questions. For this, first of all, please check this. Suppose we have fx is equal to, x cube. Okay, we need to find the derivative of this function. So we need to differentiate this dx cube by with respect to x. Okay, we are differentiating this with respect to x. Now, Krishna, can you tell me what is the formula of derivative of x to the power n?
So
What is
n
this?
into x power n minus 1.
Very good. So as per this formula, what here you will get?
3 into x power 2.
X squared. Okay. So we need to differentiate this. How we will write? We will write like this: derivative dx x squared plus sin x plus 1 by x squared. Okay. You already know how to differentiate this. You know the derivative of sin x. For this one, write this in terms of like x minus 2. And then you can apply this formula. Okay, Krishna?
Okay, sir.
Okay. Please complete this and share your answer. This one. With y minus cosec Krishna, we will do like this. We will differentiate each of the functions separately. Derivative is x minus 2 d. This will give us 2x. This will give us plus cos x. Why you are getting minus?
Oh, okay, sir. I made a mistake.
Okay. So this is the final. Good. Then please start the next question. Let's try this one.
Sir, should we rationalize the denominator?
No. There's no need to rationalize it. Okay. Doing this way. X square. We have many methods. So the best is this one. Plus c by root x. Now, here the variable are same. So what will happen? Can we write just x square minus 1 by 2 for this one?
Yes, sir.
Okay, root x means power 1 by 2. Similarly, we can write bx1 minus 1 by 2. Similarly, we can write cx minus 1 by 2. Okay?
Yes.
Okay, good.
Sir, oh,
Hotika, my voice is audible. Okay, so Hotika, you have completed the previous question. Okay, you have internet issue. That question is not completed. Please write the answer for that one. That answer is 6. And try that question is in home. Try to do that question in homework. Okay, and we have started the next step. Okay, okay, Krishna. Okay, Utvika. So please write the answer. Answer is 6. Okay, so I'm showing you what we have started. So, Utvika, we have two methods for the differentiation. First is the first principle method, which we have already discussed. And by using first principle method, we have derived these results. Hope you remember. Okay, now you need to learn these results and you need to solve the question directly by using these formulas. So please take a screenshot of this. Okay, please take a screenshot of this. I will change the slide. Please let me know once this is done. Ritika, shall we start the next slide? Okay, good. Now, next, please take the screenshot of this also. I will explain these formulas later on. We will again prove these. We will prove these formulas. Okay, so just take a screenshot of this. Okay, okay. Uh, we will now start some questions. The first question is you need to differentiate this with respect to x. So please check here. We have this formula x to the power n, okay, with respect to x. So this will give you nx n minus 1. If you are differentiating x to the power n, then you will get nx n minus 1. Now, for example, if you have x cube, okay, so this will give you what? Put this formula, this will give you 3x 3 minus 1, which will give you 3x squared. Okay, Hasvika, this clear? This clear? Okay. Okay. Similarly, suppose if we need to differentiate x to the power 4, then this will give you 4x cubed. Now, please start differentiating this. This 1 by x square, how can you solve it? 1 by x square. You can write like this, x to the power minus 2, and then you can differentiate this one. Okay, so please start this first question and tell me the answer. How can we write this? We can write in this way that we need to differentiate this with respect to x squared plus sine x plus 1 by x squared. Then you can write like this. You need to differentiate all the terms separately. So you will get this plus sine x with respect to x plus x to the power minus 2 with respect to x. Okay, was it this clear? Okay. Now please complete this, Utvika, and share your answer. Okay. Krishna, the second one is done.
Sir, we should derive an exponential form, right?
Sorry.
Or can we?
Okay. One thing is remaining that this a is a constant. Okay, a is a constant, so we will not differentiate this a. For example, if we have a into x square, and we need to differentiate this. I'm just taking example. This is not the question. This is not the original question. Suppose if we need to differentiate this, what will happen? We will write this a outside this, and then we will differentiate this one. So this will give you a into 12. Sorry, a into 12 of x. Okay, Krishna.
Okay, sir.
And one more thing, the derivative of a constant is 0. So please write this formula also, that the derivative of c is a constant, derivative of c is 0. Okay, Hosvika, please remember the derivative of any constant is 0. Okay, now Krishna, please try to do this question, second one. Krishna, you can share your answer for the second one if you have completed this.
Sir, can you solve the second one? Sir? I'm having some doubt.
Okay, okay. Please take care. First of all, we will separate it by root x plus bx by root x plus c by root x. So this can be written like this: x squared minus 1 by 2 plus bx1 minus 1 by 2 plus cx minus 1 by 2. Now this will give you a into 3 by 2 plus b into x1 by 2 plus c into x minus 1 by 2. Now differentiate. Okay. So I'm doing directly. We will differentiate each of the terms separately. Now a is a constant. It will be written here. Now formula of this is nxn minus 1. Okay. So this is what 3 by 2 x 3 by 2 minus 1. Okay, Krishna, you are getting the same answer.
Yes, sir.
Okay, similarly, this one 1 by 2 x into 1 by 2 minus 1 plus c into now again minus 1 by 2 x into minus 1 by 2 minus 1. This is equal. This will give you 3a by 2 and x is half plus b by 2 x is minus half minus c by 2 x is minus 3 by 2. Okay, Krishna, your answer is matching.
No, sir. There is some mistake in there.
Please check and let me know and which step you have done the mistake. Krishna got the mistake.
Yes, sir. I got it.
Okay, very good. Then please start the discussion. Can you tell me how can you start the third one?
So we use the formula a plus b the whole square.
Yeah. Okay. Very good. Okay, Krishna, sorry, I just missed your answer. So the first is 1, very good, plus b squared. So that means 1 by x. This will minus 2, very good. And third is 1, which will give you 0. Very good, Krishna. Yeah, start this one. So Krishna, can you tell me how can we start this?
So we multiply both the terms.
Yes, yes, very good. Please open the bracket. Hey, Krishna, you get the answer. The first is 3x square. Very good. Next is then I will solve it. So x cube minus 3x square plus 2x plus 2x square minus 6x plus 4. So x cube minus x square minus 4x plus 4. The answer is 3x square minus 2x minus 4. Very good, Krishna. This is correct. Please try this question. Krishna, please let me know if you have any doubt in this one. Hey Krishna, let me check. A cube, okay, x to the power 6 plus b cube plus 3ab. Okay, so this will cancel out and a plus b. So x squared plus 1 by x squared. Now differentiate this 6x to the power 5 and this will become minus 6x to the power minus 7 and plus 6x, and this will give you minus 6x minus 3. So your answer is absolutely correct. Very good, Krishna. Okay, then please try this question. Okay, you already know the formula of sine a plus b. So please put that formula and differentiate this. Hotika, you have just joined. So you have missed some questions. So please take this video recording from Nitkar sir. Okay, and do all the questions which we have done earlier. Okay. So Hotika, please start with this. I will write the formula for you. Last week we have done this formula. This is sine a cos b plus cos a sine b plus cos a sine b. Okay. Apply this formula and remember that sine a here. If you will open this one, I will give you the sine a cos b plus cos a sine b. Okay. Now here this sine a cos a, these are constant. These are constant. Now please try this and share your answer. Okay, Krishna, you solved it. Krishna, why the derivative of sine is minus cos? You're getting too negative.
Sir, it's for cos, right? Minus sine.
Yes, yeah. Okay, derivative of sine is cos only. And Hotvika, please try to differentiate it and share your answer, or let me know if you are facing any issue in this question.
Sir, I didn't get my mistakes.
Okay. Please check here. We need to differentiate this. Okay. We need to differentiate this one. Now, this cos is a constant, so we will not differentiate this, and we will differentiate only sine a. Similarly, this sine a is a constant, so we will not differentiate it, and we will differentiate cos x only. This is equal to cos a. Now, derivative of sine is cos x plus sine a, and derivative of cos is minus sine x. So from here we will get a cos A into cos x, and here we get a sine A into sine x. Okay, Krishna and Hotvika, this clear?
Yes, sir.
Hotvika, this clear? Okay. Okay, good. Then please start the next one. We'll drop this.
So just a second, sir.
Okay. Please note down this, confirm me, then we will start the next question.
Done, sir.
Okay, very good. Hotvika, this done. Shall we start next? Hotvika, okay, good. Please try this question. Okay, sin x plus a by cos x. You already know all the formulas. Please try this. Okay, answer. I will check it shortly. And Hotika, are you doing this question? Okay, I will also start this one. Sin x cos a plus cos x sin a. Okay, very good. By cos x. Krishna, how you have solved this denominator cos x?
So minus sin x.
But we don't have any formula till now. Okay, we have a quotient rule, but we will discuss that later on. So if we have two function fx by gx, then we can't separately differentiate this. Okay, we can't differentiate numerator and denominator separately. Okay. So as I didn't tell you about this formula, about the quotient rule, so you need to solve this question directly. You need to convert this in a normal question. How can we do that? We will separate this. Sin x cos a by cos x plus cos
Sir, am I
x.
audible now?
Yes, Hotika, you are audible.
Yes.
Cos x by cos x and sin a. Now we will write sin by cos is tan x. This is cos a plus this is cot x and this is sin a. Sorry. Now please differentiate it. Okay, Krishna, this clear?
Yes, sir.
Hotvika, this is clear?
Yes, sir.
Okay, then please differentiate this and tell me the final answer. I hope this question has been done now. Hotvika, this completed. There is only a single step remaining. Hotvika and Krishna, this done. Yes, Krishna, that is absolutely correct. Hotvika, this is done.
Is it cos A by cos square x?
No. What is okay? Cos a by cos square x, very good, because the derivative of tan is sec square x.
Hmm.
Okay, good. And here, Hotvika, what is the derivative of cot x?
One second, sir.
Let's take what is the formula for this cot x. Hotvika, the formula is minus cosec square x. Okay. Okay, Hotvika.
Okay, sir.
Please note down this, then start the. Just give me a minute. Okay. So this is your final answer, and the first type is completed. We have find the derivative by the normal method. Okay. Next, we will start the second one. Product rule of differentiation. So what does this mean? Suppose there is no need to write right now. Please wait. Suppose we have two functions. For example, fx into gx. Okay, and we need to differentiate this. We have two functions. We need to differentiate. For example, if we get x into sine x. Okay, so we can't differentiate this directly. How we can do? We can write like this: fx will remain the same. First function will remain the same. we will differentiate the second function, gx. Okay, there's no need to write right now, please wait. Then second function as it is, you will differentiate the first function. So if you have two functions which are in multiplication, then how you need to solve it? First function will remain as it is. You need to differentiate the second one, plus then second as it is, you need to differentiate the first one. It is your wish. You can write first this and then this. Okay, it will not affect your question. So just give me a minute. So this is the formula. Please note down this, and then we will start the questions. Please let me know if anyone have a doubt in the formula.
No, sir. No.
Okay, very good.
Done, sir.
Okay, good. Now very good. Utika, this done?
So 1 second, sir, I'm writing.
Okay.
Done, sir.
Okay. So I will again explain you the formula. We have two functions which are in multiplication. Then first function as it is, you need to differentiate the second one. The second as it is, you need to differentiate the first one. Take example. Please don't note this question. You need to differentiate this one, x into sine x. So we have two functions. First is x, second is sine x. As per this formula, what we will do, we will first write the first function as it is. We will differentiate the second function. Plus, we will write the second function as it is. We will differentiate the first function. Okay. So this is equal to what? X, and this is cos x plus sine x. This clear?
Yes, sir.
Okay.
Yes,
Utika,
sir.
this clear?
Yes, sir.
Okay, good. Now just give me a minute. Yeah. Please start. Okay, this was the same question. Please start the second one. Start with the second one, x cube sine x by cos x. Anyone can tell me what we will do with sine by cos, because we don't know the question form yet.
Sir, tan.
Sine tan. Very good. Okay, so write this as x cube tan x, then differentiate it. Hey Krishna, you have completed x cube sec square x plus 3x square tan x. Very good. Very good, Krishna. That is correct. Ruthika, this is completed.
No, sir, I'm not completed. I'm doing it.
Okay. Please complete it and share your answer. Ruthika, this is x cube, okay, tan x. Now these are two functions, x cube and tan x. So as per the formula, the first will remain as it is, x cube. We will differentiate the second one. That means tan x. Okay. Plus second as it is, tan x. We will differentiate the first one. So final answer we will get this x cube, this sec square x plus this is tan x and this is 3x square. Okay, Utvika, this clear?
Okay, sir. Yes, sir.
Okay, good. Uh, exponential we have not done yet, so please leave third one, leave fourth. Please do the fifth question. Okay, we have not yet done exponential, so please do the fifth question. Sorry. Okay, Krishna, you have completed this. Krishna, by which method you have done this question?
So considering x plus sec x as
First
one
function.
unit and x minus tan x as algorithm.
Okay. Let me take the answer. X plus tan x sec x, and you have differentiated this 1 minus sec x squared plus this as it is x minus tan x. Then you have differentiated 1 plus sec into tan. Okay, so you are getting the same one. This is 1 minus. Where
Yes.
did one? I guess you have missed one in both the cases. Krishna?
Yes, I think I made a mistake.
Yes, you missed that one. So please note down this is the final answer. Bothika, you have completed this?
Yes, sir. I got x plus sec x 1 minus sec square x plus x minus tan x 1 plus sec x tan
Into
x.
tan x. Very good. Bothika, this is correct.
Okay,
Okay.
sir.
Now, please note down the homework. Homework is exercise 13.2. Question number. Some questions we have already done, I guess. So mark this 13.2, question number 1 to 6. Then 7th, part first and second only. 9th, part first to 5th. 10th complete, 11th complete. Then in miscellaneous, question number 1 to 4, 11, 4, 15, 23, 22, 24, 25, and 29. Okay. And Nilkar sir will share the assignments with you tomorrow. So I will mark the question from assignment in tomorrow's class. Okay. So please note down this and try to complete it. We will discuss your doubts in the next class.
Okay, sir.
Okay, sir.
Thank you, sir.
Okay, you're welcome. Krishna, you have noted this. Shall I end the class?
Yes, sir. Noted, sir.
Okay.
Thank you, sir.
Okay, you're welcome.